Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me Router Bob. In this video, we're going to explore including aluminum extrusions in product designs. And I think this will really open your eyes to other things you can do with your ShopSabre CNC. Sean.
Hey, Router Bob.
We keep getting requests from customers about machining aluminum extrusions.
Okay.
I'd like to come up with a product to make that involves extrusions. Any ideas?
Do we need to do large extrusions, fixturing, all kinds of stuff?
I think fixturing, extrusions, panels, and how they all relate together in terms of fit of parts, those kinds of things.
I got a great idea. My oldest son, he's big into music. He's got lots of instruments, a few guitars, and he's been bugging me about a new case for a guitar. What do you think about building the case?
That's a perfect application.
All right. I'll work on getting all the materials we need. You get me a design.
I'll get the design.
Sounds good.
When I started researching this project, I found some products called road cases. And you've probably seen them. They're typically custom. The larger ones are on wheels. Normally the corners are aluminum to protect them. And they're pretty much customizable. And then I found the hardware that you use to make those. So in this video, we're going to go through how you actually put all that together to design a product. Let's get started. Okay, this is the design I came up with, and I'm using Rhino, and you could also do it in Fusion 360 and probably SketchUp, but I wanted to do the whole thing in 3D just to make it easier in the long term. So here's what you got. This is a panel. I put wood grain on there so you could see it. And then this is an extrusion, and you purchase extrusions from the company that makes the hardware. There's also a hardware, for instance, for latches, but I didn't include those on here because I really just wanted to show you what you used to do with the CNC router. In fact, if you look inside of here, you can see these extrusions. You can see where they open and close. So that's how they fit together. So it's really well thought out of. So what do I have to do to make a product like this? Well, I'm going to have to cut the extrusions to length, and I'm going to have to create the panels, and then I'm going to have to drill all the holes. And if I do this right, the router is going to do all the hard work for me, and when I'm finished, all I have to do is assemble. Now, this is how I started the project. So basically, I created this wireframe, all right? And what I actually did is I created a solid and then picked the corners and got lines on them and then got rid of the solid. So this is basically the volume that the box represents. And it happens to be 16 by 48 by 8. So that's how you start. That's what determines the size. And regardless of what size case, you start with that. And then you have the extrusions that we looked at, and you have the panels. But once you put the extrusions on there, in fact, let's take a look at an extrusion. All right, I made a copy of this extrusion, and that's what you see right here. And if you look at it, you can see there's two slots here, and these are sized based on the material you're going to use. We're using 1/4-inch ACM, and then we drill the holes because that's where the accuracy comes from. Now, on these extrusions, you're probably going to cut them with just a miter saw, and a miter saw is not nearly as accurate as a ball screw CNC router. So basically, what we want to do is everything is based on the center line here. So when we set this up in a fixture, that's what we're going to do. We're going to be indexing it that way. And if you look real closely, you'll see the design has some clearance in here, and just in case the miter saw is not accurate enough. So that's part of the idea, because my goal is to create these parts with a CNC router that are ready to assemble and the holes all line up. Now, this extrusion for the opening, once again, you can see where it has a tongue and groove setting, and it's slightly different. But the other thing about these is these are mitered in the corners. And then in practice, we'll actually put some other pieces on there to reinforce those corners. All right, now, but what we're talking about this, there's one other thing that I want to address, and that is how do you know what the panel size is going to be? Let's take a look at this piece right here. First off, how do I know what size it is? Well, I know that the panel edges are going to fit into these slots, and in this particular case, I left a little bit of space there. All right, so I know if I can pick these lines, then I know how much to offset and create that. So that's how that panel is made. So once again, that determines the size of the panel, and that also determines where the holes are. That's where the accuracy comes in, because once again, that whole process has the accuracy of the CNC machine. So once again, I copied this panel. So this is what our panel looks like. It's basically a rectangle, and it's got the hole locations down. I arbitrarily selected the hole locations, and because it's CNC, we can make those whatever we want. So on this particular design, there's a 3-hole pattern and a 7-hole pattern, and we'll look at those later when we talk about fixturing. Now, one final thing is, how do you get from this to a part we can machine in VCarve Pro, for instance? I've changed the rendering to just a shaded setup. Now let me show you how you get geometry from this. So I go in Rhino, I go to Curve from Objects, Duplicate Face Border. When I click on that, that's what I need. So you see what that is. There's the outline, and those are the holes. Then I export that out as a DXF into VCarve Pro, and that's what the toolpaths are applied to. But you see, I basically use the solid models to get all my dimensions right, so the holes all line up. All the information is built into the solid model. Then I'm just taking geometry out of it, and that's what I'm going to machine. Now let's look at fixturing, because parts don't just float in space while you're machining. We have to figure out how we're going to position, for instance, these extrusions so that we get the holes drilled accurately. So let's take a look at how you do that. What you see here is a fixture board. This happens to be 3/4 inch material. I would use plywood or a millimeter, something like that. Right, and so on the machine, then this is that fits over the front zone of the vacuum table, and I would normally have part locator pins, and this would be located with that. And then normally I put double stick tape on the edges so that once it's located, I turn the vacuum on. If I release the vacuum, it doesn't move. Okay, so now let's look into this. Let's say, for instance, let's look at what we're going to have to do. Here's our extrusion. There's the outline of our extrusion. You see, so what I want to do is I want it to be up off this table, and I want to slide it up until it hits this edge. All right, now when I make this fixture, I'm actually, once I get it in place on the table, I'm going to machine that edge just a little bit so it lines up with the x-axis perfectly. All right, and that way then I can slide this on. Now, over here, I have pusher clamps that basically push that into place and hold it in place. In our case, we're going to use 4 of them, and that's how you create the fixture. So one of the things you have to do is figure out, well, how does that work? So let's go to shading. You can kind of see where the parts are, right? So I started with this 3/4 inch, and I didn't want to have to do a bunch of fancy machining on these pieces. So I basically dropped them into this panel with dados. So this is a piece of 3/4 material. That's 3/4 material, and that's actually a piece of 1/2 inch Baltic birch, and I cut a rabbet with it, and that leaves about 30 thousandths. So that's where those parts came from. All right, let's go back to rendering. Now, to give you an idea of what's really going on here, let me right-click that. Now, there's the extrusion. Now, I made it this color so you could see it, but that's how the extrusion fits in there. And, of course, in practice, there's 4 clamps that would hold that pressed up against there. So that's how I consistently put those extrusions in place. Okay, and then you have a center mark here, and I actually cut that with a V-bit. That becomes my center line, and I mark the center point of the extrusion, and I line that up, and that's how everything gets aligned. And so then I just run the hole pattern that drills the holes in there. So that's how you fixture a part like that. So we have to fixture the extrusion, but it all starts with, where do I want it in space? How do I want the part to sit on the router so I can machine it? Okay, now here's how I actually machine that fixture. Okay, there's drilling, there's cutting a pocket, there's cutting the deeper pocket, and then there's cutting the outside. Let's take a look at that in simulation. And we just simulate all tool paths. And you notice I put holes in there also to assemble it. But so that's how I went from a concept of this is how I want the part to position, where I created the actual model, and then I actually machined the parts I needed. Now, there's one other thing that has to be machined, and that is, let's go over here. Let's go to the other sheet. This sheet would be Baltic birch. And let's look at the simulation on that. Now this is just a piece of Baltic birch I had. So that's how the parts were made for the fixture. Now let's take a look at what we do once we create the part drawings in Rhino. So for instance, this is one of those top pieces. So it's a rectangle with holes, and the hole position is critical, but once again, it was all developed off the model, so it has to line up. Now, so we bring those in, then we let VCarve Pro actually nest them, and that's what you have here, and you can see all the different parts. Now, when we actually cut these, there's two things we're going to do. First, we're going to drill all the holes, then we're going to cut the parts out. Now, remember, this material is ACM, so it's 1/4 inch. ACM is has aluminum surfaces and a plastic core. It's an unbelievable material. And we're using a white sheet, and so the finish is very durable, so we don't have to mess with finishing anything. Now, when I get ready to cut these out, this is no different than cabinet parts. You treat small parts differently. In our case, these 4 parts here are small parts. So what we're going to do is cut through those and leave an onion skin. Then we're going to return back and cut through, then we'll cut through the big ones. So let's watch that on simulation. So we'll go to our simulation. Let's go to 3D. And we should be able to see it. So the first thing that's going to happen is the 5mm drills. And that, once again, those are for the pop rivets. Okay, then the onion cut, the onion skin cut. So those small parts get cut through there. So they're still connected. So vacuum's still holding them. And then we return to do those. So those get done first, then the big parts. So now, as you see, as those get cut, those are getting cut out. But because we're cutting such a thin piece of material, they don't move around. And that's all there is to it. Now we're ready to actually send these files out to CNC Sean for machining.
All right, I just finished looking over all the files from Router Bob. Now, let's talk about all the tools we're going to need for this project. The first tool we're going to use is a 5mm brad bit. We'll be using that in the fixture, drilling all the pilot holes in the melamine and the Baltic birch. The second tool we're going to use is a white side 1.5 inch diameter 2-flute straight bit. We'll be using that to hog out a bunch of material in the melamine to give us our placements for the fixture. And then for tool 3, we're going to use a 3/8 compression bit. That'll be used just to cut out all the material within that fixture. And the last tool we're going to use for the fixture is a 45-degree V-bit for the center line. All right, now let's talk about the ACM. First tool we're going to use for the ACM is, again, a 5mm bit, but this one's going to be a through-hole bit. This will give us a really clean hole all the way through the material. Then the second tool in the ACM, we're going to use a 1/4 inch single-flute O-bit. This does a great job removing the aluminum, gets the chips out of the way, and it's going to give us a nice clean cut. All right, the final step in this, we're going to cut the foam out. We'll be using the EcoCam knife again. We're going to use an E25 blade from EcoCam. It's a 1-inch blade, exactly what we need to get all the cutting done in the foam. All right, now that we got all the tools covered, we've got a lot to get done, so why don't we get started on that fixture? Let's get to cutting.
John, the guitar case came out perfect. What a beautiful application.
It really looks nice, doesn't it? The way you did the design, all the fixturing with the holes, you know, everything worked out really well, and it also made it really simple to put everything together.
Well, you know, the accuracy of the machine shows up when you start assembling parts.
You know, especially in the CCM, check out the finish on that.
Well, I expect that this is a ball screw machine.
I do too.
Well, I hope you enjoyed the video. If you'd like to see more videos like this, be sure to subscribe to our YouTube channel. If you need more information, you can contact us at ShopSabre.com.
And be sure to check us out on Facebook and Instagram.
Thank you for watching.